How's it going, everybody? So welcome to 5-Minute Math, episode 8. Today we're going to talk about domain and range. So first, a couple of just quick definitions. So definition, the domain of a relation is a set of all allowable. There's mainly two different things you need to worry about here. There are some others, but they're mainly just two. Is a set of all allowable inputs values for the argument of the relation. What does that mean? It means what are the values that you can plug in? That's all it means, okay? What can you plug into the function or the relation? Okay, the range. The range of the relation is a set of output values for that relation. So what do you get out? Okay, input is what you put in. Domain is what you put in. Range is what you get out. Okay, so typically speaking, we talk about X being the domain and Y being the range, but it doesn't have to be specific to X and Y. You could change these around to any other type of a function. You could have Z and Q or R and S, like whatever the function would be. Once again, domain is what you're plugging in. Domain is what you get out after you plug in. Okay, so in this particular case right here for number one, this I'll call the x-axis, and then this right here I'm going to call the y-axis. So I want to know what the domain is, okay? So there's different ways of writing this, but I'll just write domain. And I want to know what are the x values it can take on. Well, if you notice, this goes on forever in that direction, all the way to negative infinity. And this, even though it goes up, it's still going to the right. So we'll still continue to go to the right forever as well. So in other words, it's all real numbers. It's everything. There's nothing that it can't be. Okay, so how do you write this? Okay, the easy way, I'm going to write it several different ways. The easy way to write this is all reals, like that. It's just a real number. Okay, that's one way you could write it. You could also write it as negative infinity to infinity, like that. Okay. Those are probably the two most common ways. The fancy way of writing it in set notation is you write it as the set of x's such that x is an element of all real numbers, okay? Like I said, that's kind of the fancy way, pretentious way of writing if you want to show off. Who wants to show off in math? But that's how you'd write it, okay? Now, what about the range? So the range is a set of y values. Like, what do you get out of that, right? So right here, when you plug in 1, it looks like you get 2. When you plug in 2, you get something, I don't know, all the way up there, maybe 9 or something. So what are the y values you can get out? Well, if you notice, the y values go up forever, but here it goes down, but it never actually gets to 0. It gets infinitely closer to it, but it actually never hits it. So the range, a couple of different ways you can write it. You could simply write it as y is going to be greater than 0, right? So everything up above 0. You could write it as 0 to infinity, or you could write it as a set of y's such that y is an element, y is greater than 0, and y is a real number. Okay, so 3 different ways you could write it. I also want to talk about this notation right here. Remember, if it's a parentheses, it means it can't actually be equal to 0. If you wrote it as a bracket, like you wrote it like this, it means it can be equal to 0. Now notice you will never write a bracket for infinity because you can never be equal to infinity. You only can go to infinity, okay? So anyway, okay, domain. So here are the two that you need to basically be worried about, okay? So domain was talking about as allowable. So one of them is the things you have to be worried about is you have to be worried about a fraction because you can't divide by 0. Okay, that's one of the things. The other thing you have to worry about is square roots. Now, we will learn about complex numbers, so technically you can take a square root of a negative number, but when we're dealing with real numbers, this thing right here has to be greater than or equal to 0. You can't take the square root of a negative number and have it be real. So let's go down here. Now, this one's kind of tricky, okay? So what is the domain of this function? Now, if you take a look here, we basically, now, I know what you're thinking. You're like, wait a minute, those are y's. Remember what I said earlier? It doesn't matter if it's x's or y's. It's just like, what are you inputting? Okay, so I'm inputting the values for y. What do I get out? I get out whatever L of y is, whatever L is. Okay, so this is a fraction. And if it's a fraction, you cannot have this thing be equal to 0. So if you don't know what makes it equal to 0, set it equal to 0. So I'm going to go y minus 2 plus y minus 8. Well, that has to be equal to 0. So 2y minus 10 has to be equal to 0. The y plus y gives you 2y. Negative 2 minus 8 gives you negative 10. Add over the 10. So you have 2y is equal to 10. Divide through by 2. You have y is equal to 5. In other words, if y was equal to 5, this denominator would be equal to 0, and the whole thing would blow up because you can't divide through by 0. Okay, so how do we write this? We're writing it in interval notation, and interval notation is what's going to look like this. Okay, now we do not want it to be equal to 0. So I can plug in anything, but I just can't plug in 0, or I just can't plug in 5, because 5 would make this thing equal to 0. So what is the interval that you can plug in? You can plug in anything all the way from negative infinity all the way up until 5. And then you can plug in anything from 5 all the way up to infinity. Now I'm going to put a little symbol in here just to like tie it all together. It's like a big U. It stands for union, which means the answer could be there or there. Okay? So this is the notation that you're looking for. Okay? And then the last one. Sorry, it's so tiny there. Okay, so find the domain of the expression, the square root of x minus 2, and then the square root of 5 minus x. So we have two different things that are going on here. You have a square root in the top in the numerator, and you have a square root in the denominator. So what do we know? I know that this thing right here cannot be negative, because you can't take the square root of a negative number, but it also can't be 0. So in other words, I'm going to take this, and I'm going to go 5 minus x has to be greater than 0. Pretty simple, solve. So add the x to their side. 5 is greater than x, or x is less than 5. Notice that the arrow is pointing at the x. Okay, so simple enough. To make the bottom work, x has to be less than 5. However, you have a square root on the top. So on the top, I'm going to go, once again, you have a square root. Now this time the top can be equal to 0, because you can have 0 on the top. So you want to go x minus 2 is greater than or equal to 0. Okay, add 2 to the other side to have x is going to be greater than or equal to 2. Okay, so in order for this expression to work, x has to be less than 5 and has to be bigger than or equal to 2. Well, if you draw it on a number line, which you should know how to do, there's 2 and there's 5. Remember, if it's equal to it, it's going to be a closed circle. And if it's less than it, it's going to be an open circle. So everything that's going to be from there to there. Now, how do you write that in set notation? Okay, so in set notation, it's going to go from 2 to 5, but it can be equal to 2. So I write it like this, 2, 5. And since it can't be equal to 5, I write it as a parentheses. Okay, so that was 5-Minute Math, episode 8, Domain and Range. And hopefully that went pretty well. And I'll see you guys next time.